Hello, good morning, good afternoon. Today we are going over Introduction to JavaScript on freecodecamp.org. Get rid of that. Let's get started. Basic JavaScript. Comment your JavaScript code. Comments are lines of code that JavaScript will intentionally ignore. Comments are a great way to leave notes to yourself and to other people who will later need to figure out what the code does. There are two ways to write comments in JavaScript. Using two forward slashes will tell JavaScript to ignore the remainder of the text on the current line. This is an inline comment. You can make a multi-line comment beginning with a forward slash and an asterisk and ending with an asterisk and forward slash. As you write code, you should regularly add comments to clarify the function of parts of your code. Good commenting can help communicate the intent of your code, both for others and for your future self. Try creating one of each type of content. Comment. So we have, this is a inline comment, and this is a multi-line comment. Let's run the tests here. We've passed. Declare JavaScript variables. In computer science, data is anything that is meaningful to the computer. JavaScript provides 7 different data types, which are undefined, null, Boolean, string, symbol, number, and object. For example, computers distinguish between numbers such as the number 12 and strings such as 12, dog, or 123 cats, which are collections of characters. Computers can perform mathematical operations on a number, but not a string. Variables allow computers to store and manipulate data in a dynamic fashion. They do this by using a label to point to the data rather than using the data itself. Any of the 7 data types may be stored in a variable. Variables are similar to the x and y variables you use in mathematics, which means they are simple. They're a simple name to represent the data we want to refer to. Computer variables differ from mathematical variables in that they can store different values at different times. We tell JavaScript to create or declare a variable by putting the keyword var, in front of it, like so. This creates a variable named rName. In JavaScript, we end statements with semicolons. Variable names can be made up of numbers, letters, and $signs or underscores, but may not contain spaces or start with a number. Use the var keyword to create a variable named myName. Hint, look at the rName example if you get stuck. So we want my name right here. Storing values with the assignment operator. In JavaScript, you can store a value in a variable with the assignment operator. This assigns the number 5 to my variable. Assignment always goes from right to left. Everything to the right of the equal operator is resolved before the value is assigned to the variable to the left of the operator. So you read this right to left, really, almost. So 5 goes into my var, and then my var goes into my num. So my num, this assigns my var and then resolves my var to 5 again and assigns it to my num. Assign the value 7 to variable A. Assign the contents of A to variable B. Oops. should be 7 and B should be A. Oh, only change code below this line. All right. So A equals 7 and B equals A. Basic JavaScript, initializing variables with the assignment operator. It is common to initialize a variable to an initial value in the same line as it is declared. Variable myVar equals 0. This creates a new variable named myVar and assigns it to initial value of 0. Define a variable A with the var and initialize it to the value of 9. Okay, variable myVar equals yes, but this is like basic JavaScript before ES6. Those lessons come later. 0, and then we want to define another one and initialize it to 9. Understanding uninitialized variables. When JavaScript variables are declared, they have an initial value of undefined. If you do a mathematical operation on an undefined variable, your result will be NaN, which means not a number. If you concatenate a string with an undefined variable, you will get a literal string of undefined. Initialize the 3 variables A, B, and C with 5, 10, and IMA so that they will not be undefined. New keyboard, man. How are you doing, Waxy? They should be fine evaluated to oh, okay, because of this. So we should be able to submit this and it's good. Understanding case sensitivity in variables. In JavaScript, all variables and function names are case sensitive. This means that capitalization matters. Capitalize myVar is not the same as, what is this, camel case? I don't know what that's called. Anyways, it is possible to have multiple distinct variables with the same name but different casing. It is strongly recommended that for the sake of clarity, you do not use this language feature. Best practice, write variable names in JavaScript in camel case. Yeah, camel case is the one that starts with a small. In camel case, multi-word variable names have the first word in lowercase and the first letter of each subsequent word is capitalized. For example, some variable, another variable name. Modify the existing declarations in assignments so their names use camel case. Do not create any new variables. So we want to do prop type. Okay, so All right, that should do it. Oh, I missed the R at the end here. Right. Add two numbers with JavaScript. Number is a data type in JavaScript which represents numeric data. Now let's try to add two numbers using JavaScript. JavaScript uses the plus symbol as an addition operation when placed between two numbers. As an example, we want to change 0 so that sum will equal 20. 10 plus 10 equals 20. Basic JavaScript, subtract one number from another with JavaScript. We can also subtract one number from another. JavaScript uses the minus symbol for subtraction. Change to 0 so that the difference is 12. Okay. Oh my god. Multiply two numbers with JavaScript. We can also multiply one number by another. JavaScript uses the asterisk symbol for multiplication of two numbers. Change 0 so that the product will equal 80. 10 times 8 equals 80. Basic JavaScript, divide one number by another with JavaScript. We can also divide one number by another. JavaScript uses the / symbol for division. Change 0 so that the quotient is equal to 2. 66 divided by 33 would be 2. Increment a number with JavaScript. You can easily increment or add 1 to a variable with the ++ operator. I++ is the equivalent of I equals I plus 1. No, the entire line becomes I++, eliminating the need for the equal sign. Change the code to use the ++ operator on my var. Learn more about arithmetic operators. Oh, okay. Oh. Decrement a number with JavaScript. You can easily decrease a variable by 1 with the -- operator. I - is the equivalent of I equals I minus 1. Let's change the code to use the -- operator on my var. So we can get rid of this. We can delete this, and we can change these two to just that. That should pass. Let's create a decimal number with JavaScript. We can store decimal numbers in variables too. Decimal numbers are sometimes referred to as floating point numbers or floats. Note, not all real numbers can accurately be represented in floating point. This can lead to rounding errors. Details here. Create a variable, myDecimal, and give it a decimal value with a fractional part. Oh, so just any one. Okay. Let's multiply two decimals with JavaScript. In JavaScript, you can also perform calculations with decimal numbers, just like whole numbers. Let's multiply two decimals together to get their product. Change to the 0.0 so that the product will equal 5.0. So 2.0 times 2.5 should equals 5.0. Basic JavaScript. Divide one decimal by another with JavaScript. Now let's divide one decimal by another. Change the 0.0 so that the quotient will equal to 2.2. So we would want 4.4 divided by 2.0 should be 2.2. Finding a remainder in JavaScript. The remainder operator gives us the remainder of the division of two numbers. 5 remainder 2 equals 1 because floor of 5 divided by 2 equals 2. 4 minus, okay, there's a remainder, yep. In mathematics, a number can be checked to be even or odd by checking the remainder of the division of the number by 2. The remainder operator is sometimes incorrectly referred to as the modulus operator. It is very similar to modulus but does not work properly with negative numbers. Set remainder equal to the remainder of 11 divided by 3 using the remainder operator. We need to equal. Awesome. Basic JavaScript. Compound assignment with augmented addition. In programming, it is common to use assignments to modify the contents of a variable. Remember that everything to the right of the equal sign is evaluated first. So we can say my variable equals my variable plus 5 to add 5 to my variable. Since this is such a common pattern, there are operators which do both a mathematical operation and assignment in one step. One such operator is the plus equals operator. So we have my var is 1, and then we add and make it equal 5. So 5 plus 6, so this should make my var 6 and return 6. Convert the assignments of A, B, and C to use the plus equal operator. Only modify the code below this line. So there we go. So A should equal 15, B should equal something, and then C is 19. Compound assignment with augmented subtraction. Like the plus equal operator, minus equal subtracts a number from a variable. So we'll subtract 5 from my var. This can be rewritten as my var minus equals 5. For the assignments for A, B, and C to use the minus equals operator. see here, compound assignment with augmented multiplication. This operator multiplies a variable by a number. This will multiply my var by 5. It can be rewritten the same way as others. My var multiplication equals 5. Convert the assignments for A, B, and C to use this operator. Oh, I deleted. Ah. It's 3. There we go. Compound assignment with augmented division. So this is the same thing. We're just using this. So we're gonna go ahead and just make this a little quicker. Right. Player string variables. Previously, we have used the code my name equals your name in strings for a string variable. Your name is called a string literal. It is a string because it is a series of 0 or more characters enclosed in single or double quotes. Create 2 new string variables, my first name and my last name. Assign them the values of your first and last name, respectively. Escaping literal quotes in strings. When you are defining a string, you must start and end with a single or double quote. What happens when you need a literal quote inside of your string? In JavaScript, you can escape a quote from considering it as an end of string quote by placing a backslash in front of the quote. So we have an example here. Alan said, and then has another quote in here, but it doesn't want to end this and make this here the string literal. So by adding the backward slash here and here, these two quotations are just kind of like ignored and are just acted as characters. This signals JavaScript that the following quote is not the end of the string, but should instead appear inside the string. So if you were to print this to the console, you would get, Alan said, Peter is learning JavaScript. Use backslashes to assign a string to the myString variable so that if you were to print it to the console, you would see I am double quoted string inside double quotes. So it wants us to use backslashes, so I am double quoted string inside double quotes. Period. Boom. Quoting strings with single quotes. String values in JavaScript may be written with single or double quotes, as long as you start and end with the same type of quote. Unlike some other programming languages, single and double quotes work the same in JavaScript. The reason why you might want to use one type of quote over the other is if you want to use both in a string. This might happen if you want to save a conversation in a string and then have the conversation in quotes. Another use for it would be saving an A tag with various attributes in quotes, all within a string. So yeah, a lot of the times You know, I'll use single quotes so that you're able to use double quotes because they're used more often in strings. However, this becomes a problem if you need to use the outermost quotes within it. Remember, a string has the same kind of quote at the beginning and the end, but if you have the same quote somewhere in the middle, the string will stop early and throw an error. So here's a good string. It's good because it's backslashing this single. This one wouldn't work because it would take this right here as string literal. Change the provided string to a string with single quotes at the beginning and end and no escape characters. Right now, the A tag in the strings uses double quotes everywhere. You will need to change the outer quotes to single quotes so you can remove the escape characters. So first we're going to swap these. Right? And then that should be good. Escape sequences in strings. Quotes are not the only characters that can be escaped inside a string. There are two reasons to use escaping characters. First is to allow you to use characters you might not otherwise be able to type out, such as a backspace. Second is to allow you to represent multiple quotes in a string without JavaScript misinterpreting what you mean. We learned this in the previous challenge. So this will give you single quote, double quote, backslash, new line, carriage return or enter, tab, space, and form feed. Assign the following 3 lines of text into the single variable myString using escape sequences. You'll need to use escape sequences to insert special characters correctly. You also need to follow the spacing as it looks above, with no spaces between escape sequences or words. Here's the text with the escape sequence. I need to change this music. So, too much. Here, yes. My brain hurts. Oh my god. Alright, here is the text with the escape sequences written out. So we have first line. This is a new line. This is a tab, and then we have a backslash, and then our second line, and then we have another new line. And that should do it, I believe. I believe. Perfect. Concatenating strings with the plus operator. In JavaScript, when the plus operator is used with the string value, it is called that word. You can build a new string out of other strings by concatenating, oh my goodness, them together. My name is Alan, plus I, yep, watch out for spaces. Concatenation does not add spaces between concatenated strings, so you'll need to add them yourself. Build my string from the strings. This is the start and this is the end using the plus operator. All right. It's complicated ass words. This is the end. Concatenating strings with the plus equals operator. You can also use the plus equal operator to concatenate a string into the end of the existing string variable. This can be very helpful to break a long string over several lines. Note, watch out for spaces. Concatenation does not add spaces between concatenated strings, so you'll need to add them yourself. Build my string over several lines by concatenating the two strings. This is the first sentence, this is the second sentence. Use the plus equal operator, using the plus equal operator. Use the plus equal operator similar to how it is shown in the editor. Start by assigning the first string to my string, then add on the second string. So we'd basically just do it like above there. So we say this is the first sentence. Oops. And then this is the second sentence. Constructing strings with variables. Sometimes you'll need to build a string, Mad Lib style. By using the concatenation operator plus, you can insert one or more variables into the string you're building. Set my name to a string equal to your name and build my string with my name between the strings my name is and I am well. So it wants us to do the same exact as up here. So we go my name is space, and then we're gonna have my name, and then and I am well. We do need our equal sign. That should do it. Appending variables to strings. Just as we can build a string over multiple lines out of string literals, we can also append variables to a string using the plus equal operator. Set some adjective and append it to my string using the plus equal operator. Learning to code is fun. Awesome. You can find the length of a string value by writing in dot length after the string variable or string literal. So we have the string Alan Peter, dot length, that's 10 characters long. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For example, if we created variable first name equals Charles, we could find out how long the string Charles is by using the first name dot length property. Use the length property to count the number of characters in the last name variable and assign it to last name length. Use bracket notation to find the first character in a string. Bracket notation is a way to get a character at a specific index within a string. Most modern programming languages like JavaScript don't start counting at 1 like humans do, they start at 0. This is referred to as zero-based indexing. For example, the character at index 0 in the word Charles is capital C. So if their first name equals Charles, you can get the value of the first letter of the string by using first name and then bracket notation with a 0. Use bracket notation to find the first character in the last name variable and assign it to first letter of last name. Hint: try looking at the first letter of a first name variable declaration if you get stuck. So first letter of last name, we want the very first letter, and that would be 0. Understand string immutability. In JavaScript, string values are immutable, which means that they cannot be altered once created. For example, following code, var my string Bob equals my string equals Bob, and then it tries to set it the first character to J, so it would be job. But you cannot change the value of my string to job because the contents of my string cannot be altered. Note that this does not mean that my string cannot be changed, just that individual characters of a string literal cannot be changed. The only way to change my string would be to assign it with a new string like this. Correct the assignment to my string so it contains the string value of hello world using the approach shown in the example above. Hello. How are you doing? Did you just give me a follow? Thank you so much for the follow. Rating craziness. How are the renovations going? I'm doing pretty good. So this says, all right, so it's trying to fix it like this and it can't. So we need to actually assign it. I am unstoppable. Use bracket notation to find the nth character in a string. You can also use bracket notation to get the character at other positions within a string. Remember that computers start counting at 0, so the first character is actually the zeroth character. Let's try to set third letter of last name to equal the third letter of the last name variable using a bracket notation. Hopefully. That really sucks when there's a lot of noise. My brother-in-law sometimes we have like a big backyard, so he'll come over and he has his quad here. His ATV. So sometimes I'll be streaming, going to stream, and he'll come home or come here early from work. And he'll start it up like right outside my window. So that's fun. Alright, so we need the third letter of last name. And we start at 0, 1, 2 to get third character. We'll use 2. Sure. So this is, we'll go to the next challenge here. Free code camp. You can go here and it has a bunch of coding challenges and projects you can build, and you can earn certifications. So yesterday I finished my responsive design. This section here. Finished this up. It's supposed to be 300 hours. It took me about 30, but I already know most of it. And today we're on JavaScript algorithms and data structures, learning basic JavaScript. So we're right here. So they're just they're a nonprofit, and they just have these like little coding challenges and explain things while you're doing them, and then you just type in your solutions and it runs some tests for you, and towards the end that's when you work on projects. So like down here we'll have some projects that we'll have to do, and then after you do all that, you plug in the URLs to your projects and you click a button and it gives you this virtual certification. So it's pretty neat, pretty cool way to learn. Yeah, it's not horrible. You can get like hints and stuff, and there's a forum, and then they have they explain everything, and then there's these little hints down here, but you can get more hints if you want. So it's really neat, and I really like it because their online IDE here has tab completion, and I believe it even in the HTML ones has emmet completion. Yeah, it's similar. All right. So we're using bracket notation to find the last character in a string. In order to get the last character of a string, you can subtract 1 from the string's length. For example, if a variable first name is equal to Charles, you can get the value of the last letter of the string by using first name.length minus 1. Use bracket notation to find the last character in the last name variable. So we have this, and we'll have to use bracket notation, and we need a number ultimately in here, so we do first name, or no, we were looking at the last name dot length, and we could do -1, or we could probably do minus. But we'll just do -1 so we don't mess with it too much. And we've passed. All right, use bracket notation to find the nth to last character in a string. You can use the same principle we just used to retrieve the last character in a string to retrieve the nth to last character. For example, you can get the value of the third to last letter of the variable first name equals Charles string by using first name.length -3. Use bracket notation to find the second to last character in the last name string. So it's pretty similar to the last one. We'll just do last name.length, and we want the second to last, so we do -2. Oh yeah. We will now use our knowledge of strings to build a Mad Libs style word game we're calling Word Blanks. You'll create an optionally humorous fill-in-the-blanks style sentence. In a Mad Libs game, you are provided sentences with some missing words like nouns, verbs, adjectives, and adverbs. You then fill in the missing pieces with words of your choice in a way that the completed sentence makes sense. Or not. Oh my. I thought I spilled my drink all over my laptop. Consider this sentence. It was really blank, and we blank ourselves blank. This sentence has 3 missing pieces: an adjective, a verb, and an adverb. and we could add words of our choice to complete it. We can then assign the completed sentence to a variable as follows. This challenge, we provide you with a noun, a verb, an adjective, and an adverb. You need to form a complete sentence using words of your choice along with the words we provide. You'll need to use the string concatenation operator plus symbol to build a new string using the provided variables my noun, my adjective, my verb, and my adverb. You'll then assign the formed string to the result variable. You also need to account for spaces in your string so that the final sentence has spaces between all words. The result should be a complete sentence. So we got a function here. Word blanks, it's passing in dog, big, ran quickly. So we could say the... And the second one is an adjective, so we'd say my adjective. Get our space in there. Actually, yes, we do need a space. And then we can say my noun, the big dog. And then we need another space. And then my verb. And another space. And my adverb. So how are you doing today? What are you doing instead of streaming? Are you still playing some Warframe? I think we did it. We did it. Store multiple values in one variable using JavaScript arrays. Hooray! With JavaScript array variables, we can store several pieces of data in one place. You start an array declaration with an opening square bracket, end it with a closing square bracket, and put a comma between each entry, like this. Sandwich, peanut butter, jelly, and bread. Modify the new array myArray so that it contains both a string and a number in that order. Alright, nest one array within another array. You can also nest arrays within other arrays, like this. This is called a multi-dimensional array. Create a nested array called myArray. So we have 1, 2, and we'll just use the examples. Boom. Access array data within indexes. We can access the data inside array using indexes, just like we did with the strings. Array indexes are written in the same bracket notation that strings use, except that instead of specifying a character, they are specifying an entry in the array. Like strings, arrays use zero-based indexing, so the first element in an array is element 0. So we have an array here, 50, 60, 70. It's looking at array with index of 0, which will give us 50. There shouldn't be any spaces between the array name and the square brackets, like array 0. Although JavaScript is able to process this correctly, this may confuse other programmers reading your code. create a variable called myData and set it equal to the first value of my array. Oh. There we go. Modify array data with indexes. Unlike strings, the entries of arrays are immutable and can be changed freely. There shouldn't be any spaces. Okay, we already read that from the last one. Modify the data stored at index 0 of my array to a value of 45. So if we say my array, and we get the 0 index, and we change it to 45, that should do it. Access multi-dimensional arrays with indexes. One way to think of a multi-dimensional array is an array of arrays. When you use brackets to access your array, the first set of brackets refers to the entries in the outermost, the first level array, and each additional pair of brackets refers to the next level of entries inside. So third value in here will equal this. We get the third value, and then we get the first one that would equal this. And if we got the third again, the first array within that, and we get the second, because it's 1, should equal 11. Using bracket notation, select an element from my array such that my data is equal to 8. So we have 8 here. So that's the first, second, third. And the second value in the third array. So my array 3 and 1 should do it. No. Oh, it's 2, 0. Yeah, there we go. Manipulate arrays with push. An easy way to append data to the end of an array is via the push function. That push takes one or more parameters and pushes them onto the end of the array. Push dog 3 and onto the end of the my array variable. So we go my array, and we're gonna push dog and 3. Basic JavaScript. Manipulate arrays with pop. Another way to change the data in an array is with the pop function. Pop is used to pop a value off of the end of an array. We can store this popped off value by assigning it to a variable. In other words, pop removes the last element from an array and returns that element. Any type of entry that can be popped off of an array, numbers, strings, and even nested arrays. Use the pop function to remove the last item from my array, assigning the popped off value to removed from my array. So we would say equals, not minus, equals my array, and we're gonna pop Alright, manipulate arrays with shift. Pop always removes the last element of an array. What if you want to remove the first? That's where shift comes in. It works just like pop, except it removes the first element instead of the last. Use the shift function to remove the first item from my array, assigning the shifted off value to remove from my array. So this will equal my array dot shift. Which will give us a John 23. My array. Manipulate arrays with unshift. Not only can you shift elements off of the beginning of an array, you can also unshift elements to the beginning of an array, i.e. add elements in the front of the array. Unshift works exactly like push, but instead of adding the element at the end of the array, unshift adds the element at the beginning of the array. Add Paul 35 to the beginning of the myArray variable using unshift. So we say my array unshift, and it's taken out in John 23, and we're gonna put in Paul 35. Shopping list. Create a shopping list in the variable myList. This list should be a multi-dimensional array containing several subarrays. The first element in each subarray should contain a string with the name of the item. The second element should be a number representing the quantity, i.e. chocolate bar 15. That's a lot of chocolate bars. There should be at least 5 subarrays in the list. So we're making lists of lists. Let's see here. What do I like? I like some beef jerky. And we'll get one of those because they're expensive. And I like, what else do I like? Peanuts. We'll get 5 of those. 5 whole peanuts. I like chips. Chips are good, but we should only get one of those because I'll kill myself with chips by eating them all. What else do I like? I like G Fuel. Can we get all of the G Fuel? 99 G Fuels. What else do we need? Cookies. We definitely need cookies. But again, only one cookies. All right. Write reusable JavaScript with functions. In JavaScript, we can divide up our code into reusable parts called functions. This is where it gets fun. Here's an example of a function. Function space function name, parameters list, and then it does the thing. You can call or invoke this function by using its name followed by parentheses like this. Each time the function is called, it will print out the message hello world on the dev console. All of the code between the curly braces will be executed every time the function is called. Create a function called reusable function, which prints hi world to the dev console. So we are going to do function reusable function and console.log hi world. And then call the function. And now we're getting hi worlds. Look at that. It's like magic. Passing values to functions with arguments. Parameters are variables that act as placeholders for the values that are to be input to a function when it is called. When a function is defined, it is typically defined along with one or more parameters. The actual values that are input or passed into a function when it is called are known as arguments. Here is a function with two parameters, parameter 1 and parameter 2. Then we can call test function with test function hello world, and we have passed two arguments, hello and world. Inside the function, parameter 1 will equal hello, and parameter 2 will equal world. So we'll pass them in, and they'll get passed to console log and be printed out. Create a function called function with arguments. So we have a function with arguments. It accepts two arguments and outputs their sum to the dev console. So we'll just do A and B. Console.log A plus B. Make it nice looking here. Then call the function with two numbers as the argument. Function with args, and 1 and 2 should equal 3. Right. Global scope and functions. In JavaScript, scope refers to the visibility of variables. Variables which are defined outside of a function block have global scope. This means that they can be seen everywhere in your JavaScript code. Variables which are used without the variable keyword are automatically created in the global scope. This can create unintended consequences elsewhere in your code or when running a function again. You should always declare your variables with var. Using var, declare a global variable myGlobal outside of any function. Initialize it with a value of 10. Side function fun1 assign 5 to oops global without using the var keyword. So using var, we're declaring a global keyword myGlobal. We're initializing it with a value of 10. Inside function 1, assign 5 to oops global without the variable keyword. So oops global is equal 5. So this is global because we've defined it outside of any functions and it's on purpose. This here is actually like hoisted up and becomes its own global. So that's why function 2 here, we shouldn't be able to see my global. What happens if we run function 2? Nothing. Okay. Well, let's run the code. Local scope and functions. Variables which are declared within a function as well as the function parameters have local scope. That means that they are only visible within that function. Here's a function in my test with a local variable location, or LOC. LOC is not defined outside of the function. Declare a local declare a local variable myVar inside my local scope. Run the tests and then follow the instructions commented out in the editor. All right. Global versus local scope and functions. It is possible to have both local and global variables within the same name. When you do this, the local variables take precedence over the global variable. In this example, we have some variable hat, it's global, but then in here, we're basically overriding it. The function my function will return head because the local version of the variable is present. Add a local variable to my outfit function to override the value of outerwear with sweater. All right. Thanks for stopping by. I hope that you have a good rest of your day. And I appreciate that follow. It's really kind of you. Return a value from a function with return. We can pass values into a function with arguments. You can use a return statement to send a value back out of a function. Plus 3 takes an argument for number and returns a value equal to number plus 3. Create a function times 5 that accepts one argument, multiplies it by 5, and returns the new value. See the last line in the editor for an example of how you can test your times 5 function. So we need a new function, times 5. We're going to pass it a number, and it's going to return that number times 5. And then we can console.log times 5, and we'll say 10. Oh, I totally got rid of everything I just did. All right, function minus 5 number, return number. Oh, this is times 5. Times 5. Understanding undefined value returned from a function. Function can include the return statement, but it does not have to. In the case that the function doesn't have a return statement, when you call it, the function processes the inner code, but the return value is undefined. So variable sum, we haven't returned anything. Just being weird, pretzel. Add sum is a function without a return statement. The function will change the global sum variable, but the return value of the function is undefined. Create a function add 5 without any arguments. This function adds 5 to the sum variable, but its returned value is undefined. Oh. So we're creating a function add 5. Doesn't take anything. This function adds 5 to the sum variable. Sum plus equals 5. Assignment with a returned value. If you'll recall from our discussion of storing values with the assignment operator, everything to the right of the equal sign is resolved before the value is assigned. This means that we can take the return value of a function and assign it to a variable. Assume we have a predefined we have predefined a function sum, which adds two numbers together. Then our sum equals sum 5 and 12. We'll call the sums function, which returns a value of 17 and assigns it to our sum variable. Call the processArg function with an argument of 7 and assign its return value to the variable processed. So processed is already set up, so we can say processed equals processArg, and we pass it 7. So what it does is it takes 7, adds 3, that will give us 10. 10 divided by 5 is 2. Process should have a value of 2. Stand in line. In computer science, a queue is an abstract data structure where items are kept in order. New items can be added to the back of the queue, and old items are taken off from the front of the queue. Write a function next in line which takes an array and a number as arguments. Add the number to the end of the array, then remove the first element of the array. The next in line function should then return the element that was removed. Add the number to the end of the array. Add the number to the end of the array, then remove the first element of the array. So return shift. Array. Push item. Alright, so next in line, we pass it the queue, and then the item that's going into it. So our code is taking the array that we've been given and pushing the item that we're given onto it, and then returning the first item. Is that right? There we go. Understanding Boolean values. Another data type is the Boolean. Booleans may only be one of two values, true or false. They are basically little on-off switches, where true is on and false is off. These two states are mutually exclusive. Boolean values are never written with quotes. The strings true and false are not Boolean and have no special meaning in JavaScript. Modify the welcome to Booleans function so that it returns true instead of false when the run button is clicked. Use conditional logic with if statements. If statements are used to make decisions in code. The keyword if tells JavaScript to execute the code in the curly braces under certain conditions defined in the parentheses. These conditions are known as Boolean conditions, and they may only be true or false. When the condition evaluates to true, the program executes the statement inside the curly braces. When the Boolean conditions evaluates to false, the statement inside the curly braces will not execute. So if a condition is true, if whatever is in here is true, then this stuff will be run. When test is called with a value of true, the if statement evaluates my condition to see if it is true or not. So this here You pass whatever here, and if it's true, we'll get it was true. If it was false, we'll get it was false. Create an if statement inside the function to return yes, that was true if the parameter was that true is true, and return no, that was false if otherwise. So if was that true, if it was true, then we're going to return yes, that was true. And if not, we're going to return no, that was not, no, that was false. And then we should run, yep. Comparison with the equality operator. There are many comparison operators in JavaScript. All of these operators return a Boolean true or false value. The most basic operator is the equality operator, equal sign, equal sign. The equality operator compares two values and returns true if they are equivalent or false if they are not. Note that the equality is different from the assignment, a single equals, which assigns the value at the right of the operator to a variable in the left. That is the thing that, like, I still sometimes will mess up. You put a single equals instead of two, or vice versa. So in this example, if my val is equal to 10, then the equality operator returns true. So the code in the curly braces will execute, and the function will return equal. Otherwise, the function will return not equal. In order for JavaScript to compare two different data types, for example, numbers and strings, it must convert one type to another. This is known as type coercion. Once it does, however, it can compare terms as follows. So you can, basically it's saying you can compare, like, these are the same, even though they're strings. Add the equality operator to the indicated line so that the function will return equal when the value is equivalent to 12. Comparison with the strict equality operator. Strict equality is the counterpart to the equality operator. However, unlike the equality operator, which attempts to convert both values being compared to a common type, the strict equality operator does not perform type conversion. If the values being compared have different types, they are considered unequal, and the strict equality operator will return false. In the second example, 3 is a number type, and 3 is a string type. So we get false because this is a string and that's number. We get true here because they're both numbers and they're equal to each other. Use the strict equality operator in the if statement so the function will return equal when value is strictly equal to 7. So we want this to be the number 7. All right, let's practice comparing different values. The last two challenges we learned about the equality operator and the strict equality operator. Let's do a quick review and practice using these operators some more. If the values being compared are not the same type, the equality operator will perform a type conversion and then evaluate the values. However, the strict equality operator will compare both the data type and value as is without converting one type to another. In JavaScript, you could determine the type of a variable or value with the type of operator. Type of 3 will return number, type of 3 as a string will return string. The compare equality function in the editor compares two values using the equality operator. Modify the function so that it returns equal only when the values are strictly equal. So we need to turn that into 3 equal signs, and they will not be equal because one is a number and the other is a string. We got 10 as a number down here, This one's a string, so it will not pass. Basic JavaScript comparison with the inequality operator. The inequality operator, not equal, or exclamation point equal sign, is the opposite of the equality operator. It means not equal and returns false where equality would return true and vice versa. Like the equality operator, the inequality operator will convert data types of values while comparing. Add the inequality operator in the if statement so that the function will return not equal when the value is not equivalent to 99. So this value, when it is not equal to 99, it should say not equal. Comparison with the strict inequality operator. The strict inequality operator is the logical opposite of the strict equality operator. It means strictly not equal and returns false where strict equality would return true and vice versa. Strict inequality will not convert data types. Add the strict inequality operator to the if statement so the function will return not equal when value is strictly not equal to 17. So here we just say exclamation for not equal to 17. Comparison with the greater than operator. The greater than operator compares the values of two numbers. If the number to the left is greater than the number to the right, it returns true, otherwise it returns false. Like the equality operator, greater than operator will convert data types of values while comparing. Add the greater than operator to the indicated line so that the return statements make sense. Change this line. So if a value is over 100, if a value is greater than 10, then that should be fine. Great. Comparison with the greater than or equal to operator. Greater than or equal to operator compares the values of the two numbers. If the number to the left is greater than or equal to the number to the right, it returns true. Otherwise, it returns false. Like the equality operator, greater than or equal to operator will convert data types while comparing. Add the greater than or equal to operator to the indicated line so that the return statements make sense. So this should say value is greater than or equal to 20, and this is greater than or equal to 10. Comparison with the less than operator. The less than operator compares the values of two numbers. If the number to the left is less than the number to the right, it returns true, otherwise it returns false. Like the equality operator, less than operator converts data types while comparing. Add the less than operator to the indicated line so that the return statements make sense. So this is saying, oh no, we're just using this. Under 25. Under 55. And that should be good. Comparison with the less than or equal to operator. So again, we just have less than or equal to, and it's going to ask us to change this. So smaller than equal to 12 would be like this. Smaller than or equal to 24 would be this. And then anything more than 24 would get passed through. Comparisons with the logical and operator. Sometimes you will need to test more than one thing at a time. The logical and operator, two and ampersands, returns true if and only if the operands to the left and right of it are true. The same effect can be achieved by nesting an if statement inside another if. This will only return true if the number is greater than 5 or less than 10. Same logic can be written like this. So we kind of save some work. Combine the two if statements into one statement, which will return yes if a value is less than or equal to 50 and greater than or equal to 25. Otherwise, it will return no. So first, if it is less than or equal to 50, or greater than or equal to 25. But then it wants us to use the what is it called? The and. We'll just do this. And we need to get rid of one of these. And that should do it. Comparisons with the logical OR operator. The logical OR operator returns true if either of the operands is true. Otherwise, it returns false. The logical OR operator is composed of two pipe symbols. This can typically be found between your backspace and enter keys. The pattern below should look familiar from prior waypoints. This will return yes only if the number is between 5 and 10. The same logic can be rewritten as this. Combine the two if statements into one statement which returns outside if the value is not between 10 and 20 inclusive. Otherwise, return inside. Ten. That should do it. Okay. I just had these backwards, so it wants the outside. All right. Introducing else statements. When a condition for an if statement is true, the block of code following it is executed. What about when the condition is false? Normally, nothing would happen. Within an else statement, an alternate block of code can be executed. So if the number is greater than 10, return bigger than 10. Else, return 10 or less. Combine the if statements into a single if-else statement. So to do this, we'll just literally just boom. Introducing else if statements. If you have multiple conditions that need to be addressed, you can change if statements together with else if statements. Convert the logic to use else if statements. So else, and we can just delete and bring this up. And then an else. Logical order in if-else statements. Order is important in if and else-if statements. The function is executed from top to bottom, so you will want to be careful of what statement comes first. Take these two functions as an example. Here's the first. And the second just switches the orders of the statements. Well, these two functions look nearly identical. If we pass a number to both, we get different outputs. Change the order of the logic in the function so that it will return the correct statement in all cases. So I believe we just want to change this to a 5 and this to a 10. And then we swap these. Chaining if-else statements. If-else statements can be chained together for complex logic. Here's a pseudocode of multiple chained if-else statements. You just do a whole bunch of them. Write chained if and else if statements to fulfill the following conditions. Okay, if the number is less than 5, we're going to return tiny. But else, if the number is less than 10, we're going to return small. Get another else if the number is less than 15, we're going to return medium. And else if the number is less than 20, we'll return large. And finally, we have well, this is supposed to just be num, first of all. So if the number is greater than or equal to 20, we'll return large. I believe we just get rid of this. Oh, this should be huge. Golf code. In the game of golf, each hole has a par, meaning the average number of strokes a golfer is expected to make in order to sink the ball in a hole to complete the play. Depending on how far above or below par your strokes are, there is a different nickname. Your function will be passed par and strokes arguments. Return the correct string according to the table, which lists the strokes in order of priority, top, highest, and bottom, lowest. Par and strokes will always be numeric and positive. We have added an array of all the names for your convenience. Okay. So, if strokes is equal to 1, and return names 0. And else if strokes is less than or equal to par minus 2, we're going to return names 1. And then we have another else if strokes so that should give us birdie. Need the fourth index, which will be bogey. Slaps roof of JavaScript. This object cannot read property of undefined. That's an excellent joke. Names 5. Oh, no. Greater than or equal to par plus 3. Let's give this little breathing room here. How are you doing today, the Firewire? Hope you're having a good day. Brushing up. I've been doing HTML and CSS and JavaScript and PHP for like 18 plus years. I'm just doing this to get the certifications, kind of add something to my CV, you know. What's up, Sophie? How are you doing today? You working today? And this should be that. Let's see if we did it. We didn't do it. Lunch break. What's for lunch? Should return bogey. Look at that. You're here just in time to be called out. I wonder how much more of this there is today. Let's see. Let's see. Done quite a bit, but we got quite a bit to go. All right, let's keep to it then. Selecting from many options with switch statements. Oh, my favorite. If you have many options to choose from, use a switch statement. A switch statement tests a value and can have many case statements, which define various possible values. Statements are executed from the first match case value until a break is encountered. Here is a pseudocode example. So we have a switch that's getting past a number. Some eggs, that's it. I had 4 pieces of beef jerky and some applesauce. I am very hungry right now. Very, very hungry. But I need to stop eating so much. So we're gonna sort of kind of fast. Not really a complete fast, but we're eating very light. Yes, it is. I've been like 8 pounds above my low for a bit now. I'm glad I'm not gaining all the weight back that I lost, but I want to keep going down, you know? All right, so we're going to write a switch statement which tests the value and sets answer for the following conditions. Okay. So we have our switch. It's going to test the value. And in this case, so 1 will be alpha, 2, beta, gamma, and delta. So case 1. And then we have answer is going to equal alpha. And then we need a break. And then we'll have case 2. And that will make the answer equal beta. And then another break. And case 3. The answer will equal gamma. And another break. And case 4. Answer will equal delta. And a break. Boom. Adding a default option in switch statements. In a switch statement, you may not be able to specify all possible values as case statements. I am warm right now. Turned off my AC so I could close my blinds. Alright, so instead you can add the default statement, which will be executed if no matching case statements are found. Think of it like the final else statement in an if-else chain. Default statement should be the last case. So we have our default here. Write a switch statement to set the answer to the following conditions. So we have another switch here. We're testing against the value that we're passing the function. Okay, so case A, we're going to return apple. And we're going to break. We're going to copy and paste this 3 times so I can save a bunch of typing. So we got B and C and bird and cats. Now we need our default. Which will return stuff. Oh. We're not returning. That's sad. Answer equals. So let's just take this. Answer equals stuff. And we need a break here too. And that should do it. And it's going to switch of stuff past 1. We'll go through all these. Is A1 no? Is B1 no? Is C1 no? So we'll do our default. So it should put out, answer should be stuff. Multiple identical options in switch statements. If the break statement is omitted from a switch statement's case, the following case statements are executed until a break is encountered. If you have multiple inputs with the same output, you can represent them in switch statements like this. So case 1, 2, and 3, we're going to do this. Case 4, we'll do that. Write a switch statement to set the answer for the following ranges. Alright, so we have another switch. It's going to get the value. And we'll say case 1, case 2, and case 3. For these, the answer will be high or low. And then we're going to do a break. And then case 4, case 5, and case 6 will be, answer will be mid. And then case 7, case 8, and case 9, the answer will be high. And another break. Got him. Replacing if-else chains with switch. If you have many options to choose from, a switch statement can be easier to write than many chained if-else if statements. The following, if value is strictly equal to 1, or all this can be rewritten to this. Which doesn't really seem better to me, but okay. It's easier to reason about, I guess. So it wants us to take this and convert it to a switch. All right. Thanks for stopping by. I appreciate it. Hope you have a good rest of your workday. Maybe we can play some games later if you're down. So we'll switch this to a switch. And we're looking at the value. So for case Bob, the answer will be Marley, and we'll add a break. And then the case is 42. The answer, well, actually, we can just take this, pop it up here, copy this break. So that's done. If the case is 1, I'll do another break here. Get rid of this. And finally, we have case 99. Another break. And then case 7. And we'll pull this answer up, tab it, give it another break, and delete this line. We need to leave this, close out this curly brace right here. That should do it. Okay, this is supposed to be lowercase. That's fine. Returning Boolean values from functions. You may recall from comparison with the equality operator that all comparison operators return a Boolean true or false value. Sometimes people use an if-else statement to do a comparison like this. If A is equal to return true, else, but there's a better way to do this. Since equal is the strict equals returns true or false, we can return the result of the comparison. Fix the function is less to remove the if-else statements. So we'll just return A is less than B, right? Then we can get rid of this. Return early pattern for functions. When a return statement is reached, the execution of the current function stops and control returns to the calling location. Basically, it's saying, we have this example here. It's going to console log hello, return world, and console log bye bye will not be put out because we've hit this return statement. So basically, we're here, it does this, and then we're returning, or it hits this, and moving on to the next line, which there's nothing. Modify the function A/B test so that if A or B are less than 0, the function will immediately exit with a value of undefined. Counting cards. In the casino game Blackjack, a player can gain an advantage over the house by keeping track of the relative number of high and low cards remaining in the deck. This is called card counting. Having more high cards remaining in the deck favors the player. Each card is assigned a value according to the table below. When the count is positive, the player should bet high. When the count is 0 or negative, the player should bet low. You will write a card counting function. It will receive a card perimeter, which can be a number or a string, and increment or decrement the global count variable according to the number's value. See table. The function will return a string with the current count and the string bet if the count is positive, or hold if the count is 0 or negative. The current count and the player's decision bet or hold should be separated by a single space. Hint, do not reset count to 0 when the value is 7, 8, or 9. Hint, do not return an array. Hint, do not include quotes in the output. So let's do a switch. We're going to look at the card. And if the cards are 2, 3, 4, 5, or 6, we're going to do this thing and break. If the case is 7, 8, or 9, we don't really do anything. And case is 10 or Jack or Queen or King or Ace. And then if it's any of these, we're gonna say count equals, we're gonna just count plus plus, right? And if this, we're not doing anything, and if it's this, count minus minus. So if the count is 0, we're gonna just do this. And then we'll say if so we don't need this actually. Build JavaScript objects. You may have heard the term object before. Objects are similar to arrays, except that instead of using indexes to access and modify their data, you access the data and objects through what are called properties. Objects are useful for storing data in a structured way and can represent real-world objects like a cat. Here's an example cat object. We have a cat, we have an object, its name is Whiskers. It has 4 legs, 1 tail, and its enemies are water and dogs. In this example, all the properties are stored as strings, such as name, legs, and tails. However, you can also use numbers as properties. You can even omit the quotes for a single word string properties as follows. However, if your object has any non-string properties, JavaScript will automatically typecast them as strings. Make an object that represents a dog called myDog right here, which contains the properties name, legs, tails, and friends. Awesome. Accessing object properties with dot notation. There are 2 ways to access the properties of an object. Dot notation, using a period, and a bracket notation, similar to an array. Dot notation is what you use when you know the name of the property you're trying to access ahead of time. Here's an example of using dot notation to read an object's property. So we have this object here, and the prop1 val is going to equal my object.prop1. So will equal value 1, and this will equal value 2. Read in the property values of a test object. This is a little too... Set the variable hat value equal to the object's property hat, and set the variable shirt value equal to the object's property shirt. So we want to change these 2 lines here. So we're going to do .hat and .shirt. Accessing object properties with the bracket notation. The second way to access the properties of an object is bracket notation. If the property of the object you are trying to access has a space in its name, you will need to use bracket notation. However, you can still use bracket notation on object properties without spaces. Here's an example of using bracket notation to read an object's property. Note that the property names with the spaces in them must be in single quotes, single or double. Read the value of the properties an entree and the drink of a test object using bracket notation and assign them to the entree value and drink value. So here it just, since we know the names, we can just say and then we want to pull the drink as well. Great. Accessing object properties with variables. Another use of bracket notation on objects is to access a property which is stored as the value of a variable. This can be very useful for iterating through an object's properties or when accessing a lookup table. Here's an example of using a variable to access a property. We have a variable dogs, which is an object full of dogs. And we have dog Fido, who's a mutt, Hunter, who is a Doberman, and Snoopy, who is a Beagle. They're my dog Hunter. They're my breed dog's my dog. Alright. Another way you can use this concept is when the property's name is collected dynamically during the program execution as follows. That we do not use quotes around the variable name when using it to access the property because we are using the value of the variable, not the name. Use the player number variable to look up player 16 in test object using bracket notation, then assign the name to the player variable. So this is going to equal test object dot. And we're going to use bracket notation. We do this. Player number is 16. And then the player, we're using player number. I got it. Gotcha. Updating object properties. After you've created a JavaScript object, you can update its properties at any time just like you would update any other variable. You can use either dot or bracket notation to update. For example, let's look at our dog. Variable our dog is named Camper. He has 4 legs, a tail, and everything is his friend. Since he's a particularly happy dog, let's change his name to Happy Camper. Here's how we update his object's named property. Our dog name is equal to Happy Camper, or our dog using bracket notation name is Happy Camper. Now when we evaluate our dog name, instead of getting Camper, we'll get this new name, Happy Camper. Update the my dog object's name property. Let's change her name from Coder to Happy Coder. So we're gonna say my dog dot name is equal to Happy Coder. Add new properties to a JavaScript object. You can add new properties to existing JavaScript objects the same way you would modify them. Here's how we would add a bark property to our dog. Our dog.bark equals bow wow, or our dog bark equals bow wow, using bracket notation. Now when we evaluate our dog.bark, we'll get his bark, bow wow. Add a bark property to my dog and set it to a dog sound, such as woof. You may use either dot or bracket notation. So my dog.bark is going to equal woof. not bar. Roof. Delete properties from a JavaScript object. You can also delete properties from objects like this. Delete rdog.bark. I did not know that. Delete the tails property from my dog. You may use either dot or bracket notation. What happened to his fucking tail? It's fucking mean. Using objects for lookups. Objects can be thought of as a key value storage, like a dictionary. If you have tabular data, you can use an object to look up values rather than a switch statement or an if-else chain. This is most useful when you know that your input data is limited to a certain range. Here's an example of a simple reverse alphabet lookup. Convert the switch statement into an object called lookup. Use it to look up val and assign it to the associated string to the result. So we are creating lookup, and that's going to equal this object, and then let's see here. We're going to pull these up. Actually, you know what? We're just going to add multi-cursors. We're going to delete all these cases, so that gives us our we can do that. And we'll just cut these out. And then we'll add a bunch more multi-cursors. We'll delete all these, add a comma. And this last one doesn't need a comma. And then we need to change the switch to var lookup. So this is going to return lookup based on the value that we sent. Oh. There we go. Testing objects for properties. Sometimes it is useful to check if the property of a given object exists or not. We can use the hasOwnProperty property name method of objects to determine if that object has the given property name. hasOwnProperty returns true or false if the property is found or not. Modify the function check object to test my object for check prop. If the property is not found, return that property's value. If the property is found, return that property's value. If not, return not found. Your code here. So we're checking the object. So we're going to say return, and then if my object that has own property check prop let's see here. We're going to do it this way just to make it so I don't have to use shorthand. If it does, we're going to return and if not, we're going to return not found. Is that right? That's right. Manipulating complex objects. Sometimes you may want to store data in a flexible data structure. A JavaScript object is one way to handle flexible data. They allow for arbitrary combinations of strings, numbers, booleans, arrays, functions, and objects. Here's an example of a complex data structure. This is an array which contains one object inside. The object has various pieces of metadata about an album. It also has a nested formats array. If you want to add more album records, you can do this by adding records to the top level array. Objects hold data in a property which has a key value format. In the example above, artist Daft Punk is a property that has a key of artist and a value of Daft Punk. JavaScript object notation, or JSON, is a related data interchange format used to store data. You will need to place a comma after every object in the array unless it is the last object in the array. Add a new album to the MyMusic array. Add artist and title strings, release year number, and format array of strings. So since this we're going to have to add a comma. And then we have our new record and artists. We're just going to cheat on this. We're just going to do CD. I don't know. We'll put false just for fun. I don't know. Formats. And this wants at least 2. Accessing nested objects. The subproperties of objects can be accessed by chaining together the dot or bracket notation. Here's a nested object. So we can get our storage cabinet, top drawer, folder 2, secrets. Access the my storage object and assign the contents of the glove box property to the glove box contents variable. Use bracket notation for the properties with a space in their name. We're changing this line and we want my storage. And we're looking for the glove box, so we're going to say .car inside the glove box. Should give us maps. Accessing nested arrays. As we have seen in earlier examples, objects can contain both nested objects and nested arrays. Similar to accessing nested objects, array bracket notation can be changed to access nested arrays. Here's an example of how to access a nested array. Retrieve the second tree from the variable myPlants using object dot notation and array bracket notation. So we're going to get the first myPlants. We want the second one, so we're going to do 0. And then list. Retrieve the second tree. Okay. So myPlants, we're going to do 1 to get the second one. And then we're going to do that list. And we're going to get 1 for the second one as well. Should be right, yeah. Record collection. You are given a JSON object representing a part of your musical album collection. Each album has several properties and a unique ID number as its key. Not all albums have complete information. Write a function which takes an album's ID, like 2,548, a property, prop, like artists or tracks, and a value like addicted to love to modify the data in this collection. If prop isn't tracks and value isn't empty, update or set the value for that record album's property. Your function must always return the entire collection object. There are several rules for handling incomplete data. If prop is tracks, but the album doesn't have tracks property, create an empty array before adding the new value to the album's corresponding property. If prop is tracks and value isn't empty, push the value into the end of the album's existing tracks array. If a value is empty, delete the given prop property from the album. Hence, use bracket notation when accessing object properties with variables. Push is an array method you can read about on the Mozilla Developer Network. You may refer back to manipulating complex objects, introducing JavaScript object notation JSON for a refresher. So it's going to return so if prop is not equal to tracks, and the value is not empty. Prop isn't tracks and value is an empty. Update or set the value for that record album's property. So we're gonna say collection prop, no, collection ID prop equals value. Else if the prop is tracks, we're going to check the album doesn't have a tracks property. So collection ID has own property tracks. If it does have, we're going to do that. And else, we're going to do something else. Prop is tracks, and the value isn't empty. Push, let's see here. Collection ID dot tracks push the value, else delete collection empty, delete the given property from the album. So let's try to rework this. If value does not equal this, then we're in here. And otherwise we're in here. Now if the prop does not equal tracks, we're in here, else we're in here. little nicer. There we go. I'm messing that part up again. There we go. Iterate with JavaScript while loops. You can run the same code multiple times by using a loop. The first type of loop we will learn is called a while loop because it runs while a specified condition is true and stops once that condition is no longer true. Let's try getting a while loop to work by pushing values to an array. Push the number 0 through 4 to my array using the while loop. So var I equals 0, and then while I is less than 4, we're going to say my array dot push oh no. Iterate with JavaScript for loops. You can run the same code multiple times by using a loop. The most common type of JavaScript loop is called a for loop because it runs for a specific number of times. For loops are declared with 3 optional expressions separated by semicolons for initialization, condition, final expression. The initialization statement is executed one time only before the loop starts. It is typically used to define and set up your loop variable. The condition statement is evaluated at the beginning of every loop iteration and will continue as long as it evaluates to true. When condition is false at the start of the iteration, the loop will stop executing. This means if condition starts as false, your loop will never execute. The final expression is executed at the end of each loop iteration prior to the next condition check and is usually used to increment or decrement your loop counter. In the following example, we initialize with I equals 0 and iterate while our condition I is less than 5 is true. We'll increment I by 1 in each loop iteration with I++ as our final expression. Use a for loop to work to push values 1 through 5 into my array. want 1 through 5, huh? Sweet. Iterate odd numbers with a for loop. For loops don't have to iterate one at a time. By changing our final expression, we count by even numbers. We'll start at I equals 0 and loop while I is less than 10. We'll increment I by 2, each loop with I plus equals 2. Our array will now contain 0, 2, 4, 6, and 8. Let's change our initialization so we can count by odd numbers. Push the odd numbers 1 through 9 to my array using the for loop. So we're going to do var I equals 0, I less than 10, and then I if we start at 1 and then add that should work. Maybe later. Count backwards with a for loop. A for loop can also count backwards so long as we can define the right conditions. In order to count backwards by 2s, we'll need to change our initialization condition and final expression. We'll start at I equals 10 and loop while I is greater than 0. We'll decrement I by 2, each loop with I minus equals 2. Our array will now contain 10, 8, 6, 4, and 2. Let's change our initialization and final expression so we can count backwards by 2s by odd numbers. Push the odd numbers 9 through 1 to my array using... yeah, okay. And we need to change this to my array since we copy and pasted. Iterate through an array with a for loop. A common task in JavaScript is to iterate through the contents of an array. One way to do this is with a for loop. The code will output each element of the array to the console. Remember that arrays have zero base numbering, which means the last index of the array is length minus 1. Our condition for this loop is I is less than array.length, which stops when I is at length minus 1. Declare and initialize a variable total to 0. Use a for loop to add the value of each element of my array to total. So var total equals 0. And then we're going to do for variable I equals 0. I is less than my array.length. And then I plus plus. Total will equal my array number at that index. Plus. Well, we can just do this. Plus equals. That should do it. My array is not defined. Oh, we gotta change this one too. There we go. Nesting for loops. If you have a multi-dimensional array, you can use the same logic as the prior waypoint to loop through both the array and any subarrays. Here's an example. This outputs each sub-element in array 1 at a time. Note that for the inner loop, we are checking the length of array I, since array I is itself an array. Modify the function multiply all so that it multiplies the product variable by each number in the subarrays of array. So for variable I equals 0, I is less than array length. And then we're going to increment this by 1. Oh my goodness. And then in here for variable j equals 0. Oh my goodness. J, every time j is less than the length of the array I, its length. Then we'll increase that one. So product times equals j. Right? We want to do, that's an array, so we do array I j. I believe that's right. Let's run the code. Oh. There we go. Spelling error. Typo. Iterate with a JavaScript do while loops. You can run the same code multiple times by using a loop. The next type of loop you'll learn is called a do while loop, because it first will do one pass of the code inside the loop no matter what, and then it runs while a specified condition is true and stops once the condition is no longer true. Let's look at an example. This behaves just as you would expect with any other type of loop, and the resulting array will look like 0, 1, 2, 3, 4. However, what makes the do while different from other loops is how it behaves when the condition fails on the first check. Let's see this in action. Here's a regular while loop that will run the code in the loop as long as I is less than 5. Notice that we initialize the value of I to be 5. When we execute the next line, we notice that I is not less than 5, so we do not execute the code inside the loop. The result is that our array will end up with nothing added to it, so it will still look like this empty array when all the code in the example above finished running. Now take a look at a do while loop. In this case, we initialize the value of I as 5, just like we did with the while loop. When we get to the next line, there's no check for the value of I, so we go to the code inside the curly braces and execute it. We will add one element to the array and increment I before we get to the condition check. Then, when we get to checking if I is less than 5, see that I is now 6, which fails the conditional check. So we exit the loop and are done. At the end of the above example, the value of our array is 5. Essentially, a do while loop ensures that the code inside the loop will run at least once. Let's try getting a do while loop to work by pushing values to an array. Change the while loop in the code to a do while loop so that the loop will push the number 10 to my array and I will be equal to 11 when your code finishes running. We're changing this to a do while. So we're going to do all this stuff while that. Run these tests. Profile lookup. We have an array of objects representing different people in our contacts lists. A lookup profile function that takes name and a property of prop as arguments has been pre-written for you. The function should check if name is an actual contact's first name and the given property prop is a property of that contact. If both are true, then return the value of that property. If name does not correspond to any of the contacts, then return no such contact. If prop does not correspond to any valid properties of a contact found to match the name, then return no such property. So we got this lookup here. We're going to pass the name and a property. See here, while I is less than contacts.length, and then we're gonna bump that by 1. That's a 4. So we're going to go, and for each of these, we're going to look for a name. So we're going to do if contacts I first name is equal to is not oh. So if the contact is the first name of this, then we're going to look if this contact has own property prop, and if it does, Then we're going to return contact I prop and if it doesn't, we're going to return this needs another parentheses here. No such property. We don't need an else here. Return no such contact. Let's give this a run. Change these to be the right spelling. We need a double equals because we're not setting it. We're checking to see if the values are equal. So that should fix it. I mean, that should work, right? What? I'm confused as to why this isn't working. I really don't get it. Line 39. Oh, you're right. You're right. It does need an else. All right. Yep. Or is that not right either? That's not right either. All right, so we cycle through this section. Oh. Tap. Sam who? You are the winner. I've been doing this for 3 hours now. So, thank you. Yes. All right. Generate random fractions with JavaScript. Random numbers are useful for creating random behavior. JavaScript has a math random function that generates a random decimal number between 0 and not quite up to 1. Thus, math random can return a 0 but never quite return a 1. Like storing values with the equal operator, all function calls will be resolved before the return executes, so we can return the value of the math random function. Change random fraction to return a random number instead of returning 0. You literally just want me to do this? Generate random whole numbers with JavaScript. It's great that we can generate random decimal numbers, but it's even more useful if we can use it to generate random whole numbers. Use math random to generate random decimal, multiply that random decimal by 20. Use another function at math floor to round the number down to its nearest whole number. Remember that math random can never quite return a 1, and because we're rounding down, it's impossible to actually get 20. This technique will give us a whole number between 0 and 19. Putting everything together, this is what our code looks like. We are calling math random, multiplying the result by 20, and then passing the value math floor function to round the value down to the nearest whole number. Use this technique to generate and return a random whole number between 0 and 9. So we need math.floor, and we got our math.random, and we're going to times that by 10. Generate random whole numbers within a range. Instead of generating a random number between 0 and a given number like we did before, we can generate a random number that falls within a range of two specific numbers. To do this, we'll define a minimum number min and a maximum number max. Here's the formula that we'll use. Take a moment to read it and try to understand what is happening. So we're going to take math random times it by the max, the product of max minus min plus 1. Create a function called random range that takes a range my min and my max and returns a random number that's greater than or equal to my min and is less than or equal to my max inclusive. All right. Math dot floor. We're going to take math.random and times it my max minus my min. Hate using arrow keys. Use the parseInt function. The parseInt function parses a string and returns an integer. Here's an example. The above function converts the string 007. Have you heard of our Lord and Savior Vim? I have. As a matter of fact, I use it, and that's why arrow functions suck in this editor. Magic. No arrow keys. Oh, yes. Delete lines. Paste lines. Go to the end, or the beginning. Go to the end. GG for the top, big GG for the bottom. Yes, I'm a Vim fan. I love the Vim. I need to learn more of the Vim. Even the basic stuff is like, oh my god, it's way better. The first character in the string can be converted into a number, then it returns not a number. Use parseInt in the convert to integer function, so it converts the input string into integer and returns it. Boom. I am not a new programmer in general, and I'm not new to JavaScript. So I started HTML and CSS like 18 plus years ago, and then that was followed by PHP and then JavaScript. So I've been doing this for a while. But man, I do not do like nested ifs a lot. So more of a functional, like using pipes and stuff. This is like old school style shit that I haven't done in a long time. All right, use the parse int function with radix. Radix? So yeah, I'm just doing this to get the certifications. And just to show that, you know, people that have been doing this for 18 years can still mess up. So I've done that today. Takes a second argument for the radix, which specifies the base of the number. In the string, the radix can be an integer between 2 and 36. The function calls look like this. Here's an example. Oh no, it's totally with that mess up there. I mean, that was pretty basic. That's pretty basic. I'm glad that you're here because I felt stupid. I knew it was something because I mean, everything there was right. It was just in the wrong order. I just had a line messed up. So I was like, why is this wrong? So confused. Okay, so we want to convert this binary to an integer. So we'll use return parse int, and we'll pass the string, and we want it in base 2. How long have you been yeah. How long have you been developing? What's your favorite languages? Use the conditional ternary operator. The conditional operator, also called the ternary operator, can be used as a one-line if-else expression. The syntax is condition if the statement is true, and then if the statement is false. The following function uses an if-else statement to check a condition. It can be rewritten using the conditional operator. Use the conditional operator in the check equal function. Check if two numbers are equal or not. Function should return either true or false. Java, huh? What kind of stuff do you make in Java? Do you do like apps? Are you an Android developer? Or just Java? My butt hurts. I just want to be done with the section. So we're gonna return if A is equal to B, then we will return true, and if not, we'll return false. Am I working a bank right now? Rust, huh? You do programming for the bank? Use... It's not quite as horrific as it sounds. I hope not. Use multiple conditional ternary operators. In the previous challenge, you used a single conditional operator. You can also chain them together to check for multiple conditions. Yeah, I'm a back-end developer. That's cool. I'm a full stack developer, so I do front end, but I would agree with you in that I try to avoid it because it's honestly, it's not harder than back end work, but it's more tedious. We're doing multiples. Yeah, that's the other thing too, is you gotta be like a decent designer. Have an eye for stuff. I have an eye for stuff, but then I'm lazy. So I'm like, oh yeah, this looks like crap, but you know, whatever. All right, so we want to return if the number is positive, so if it's greater than 0, then we're going to okay, we got to return, okay, positive. And if it's not that, then we're going to do another check and see if the number is less than 0. And if it is, then we're going to say negative. And if not, we're going to say 0. Or if it is, we're going to say negative, and if not, we're going to say 0. I'm in a bit of a pickle at the moment. I ignored the warning signs now. I have quite bad RSI, so I'm actually dictating all of this text to you via my phone. RSI, what is that? Probably some bad thing I should probably know about. That's it. We're done with basic JavaScript. We're done. We're done. We did all of this today. Oh, regular expressions is gonna be lovely. Repetitive strain injury. Oh yeah, that's not good. Yeah, man, when I was I don't do like I try to limit the amount of actual like coding I do a day. I've worked for places that, you know, they want you there like 10 hours a day doing code, and it's just like your eyes and your hands and everything just hurts. I hurt from sitting here for 3 hours right now. So I stopped working for places because I couldn't really find a place that had a healthy approach to managing their employees. So now I'm very strict. I limit how much time I will work on it a day. I also use something called a power ball. And it's supposed to help like strengthen your muscles in your hand and stuff. So hopefully I do not come across that. I'm worried about my back right now. I need something to Correct my posture. Oh, man, 3.5 hours for this section. And tomorrow we're doing ES6, will be a little nicer. I'm not looking forward to regular expressions. And projects. Hopefully the projects will be fun. Anyway, Sam, I really appreciate you stopping by, and yeah, I have a sale from Herman Miller. I'm really fond of the Aeron chairs, but I couldn't afford one when I bought one for my home office. So I have a sale, but the cushioning is not good because I'm a heavy guy. I weigh like 300 plus pounds. Even though the chair's weighted for like 350, like the padding on it is not good. So it hurts my butt. So I got like a cheaper one from like Staples, Office Max. That's a little more cushy. I really would like. I want to sell my sale and try to get an Aeron. It really is worth it. I agree. Anyway, like I was saying, I appreciate you stopping by, for helping me out there. I was stuck. I will be back tomorrow afternoon, 1 p.m. EST, for the next section here. ES6. Introduction to the ES6 challenges. If you're into this stuff, man, give me a follow, and hopefully I'll see you tomorrow. Hope you have a good one too. And also thank you to Sophie and anybody else who stopped by and gave me a watch. I will be back later tonight, 8 p.m. EST, for some Clash Royale. Like games and Clash, and I hope to see you there. Later.